So first of all, why do we use differentiation? What is the point? Well, we use differentiation to be able to find the gradient of a curve at any point. And I should add on there along the curve. So that's what differentiation is used for, to find the gradient of a curve at any point along that curve. So if I take, for example, two graphs, and if we had the graph of y equals x, and if we had the graph of y equals x squared, as we can see, this is a straight line, and this is a curve. Now on a straight line, the gradient at any point on this straight line is always going to be the same, and in this case, the gradient is 1. However, here, if I was to look at this point, I can see there that the gradient's negative because the line's going downwards. If I look at this point here, the turning point at the origin, the gradient is in fact 0. So here's negative, here's 0, and if I was to look at this final point here, we can see that the gradient is there positive. So how can we work out the gradient of this curve? And that's where differentiation comes in. Let me introduce the rule to you. So if we have a polynomial where y equals ax to the power n, where a and n are real values, okay, they can be fractions, negatives, or in fact just integers, then we have a rule to be able to differentiate this, and the notation that we use for the derivative is dy on dx, the change in y on the change in x, or in other words, the gradient. And if I want to differentiate any polynomial in this form, I multiply the power down to get my n power here, and I multiply that by ax, as we've got from here, to the n minus 1. And in words, that's times by the power and minus 1 from the power. And it's got to be done in that order. So we times by the power. So this is where the n comes to the front here. We then multiply by that n and minus 1 from the power. So let's have a look at a few examples. So example number 1 says y equals x squared, and we want to find dy on dx. And in terms of dy on dx, that's the gradient. And therefore we need to differentiate. So using our rule of y equals ax to the n, dy on dx, we times and take, so the power is going to come down to the front, and then ax to the n minus 1, because we minus 1 from the power. Here we've got y equals x squared, so the 2 is the n, that's going to come down to the front, to give us a big 2. We're going to multiply that by our a, well we don't have an a, because it was actually a 1 here, wasn't it? We just don't bother writing that. Times by an x, and we're going to take 1 from the power, so our power becomes 1, and therefore we can say dy on dx is going to be 2x, and then we don't need to add that power as a 1, and that is our answer. Let's have a look at another example. So now we're given y equals x cubed, and we want to find dy dx, or the gradient or the derivative. Now just make sure that you know what's going on. This is what our y equals x cubed graph looks like. Okay, and what we're trying to do is we're trying to say if I was given this point here, the gradient would be positive, and I'd actually be able to put an x value into my dy dx to find the gradient at that point, to also find the gradient at that point, and that point, and that point, and in fact any point along this curve I would be able to find the gradient. So that's the use of differentiation like we touched on in at the start of this video. So now what we want to do is we want to find dy on dx. So I'm going to first of all start by writing that down, and I'm going to try and do this one without looking at the rule. So if we remember, we times our power down to the front, and then we multiply everything by our power and reduce the power by 1. So my power is going to be coming to the front to get a 3. I'm then going to multiply that by x, and I'm going to reduce my power by 1, so it then becomes a 2. And we can't get this any simpler, so that's my answer. So if I wanted to work out the gradient at any point along this curve, I would be able to slot in an x value into this dy dx formula, and it would give me the gradient on the x cubed graph. Okay, let's now have a look at what if we were then asked y equals 3x squared and we want to work out dy dx. How would we do that? So I'm using my previous answer here, but in terms of y, and I want to differentiate 3x squared. We're going to do the exact same thing. So I'm going to start off by writing dy dx. And what we're going to do is we're going to times by our power, bring it to the front, and then multiply our power by everything and reduce the power by 1. So bringing this power down to the front, I get a big 2. We're multiplying that by 3x to the power 1, because we have reduced our power by 1, so the 2 has now become a 1. Now, writing dy dx again, I can multiply this 2 with everything inside this bracket. And what that basically means is 2 times 3x to the 1, which is just 2 times 3x, because we don't really need to write that 1. So that's what we're actually doing here. So then our answer is 6x, and that is the derivative of 3x squared. Now let's have a look at an example where our power is negative. So now we've been given y equals 3x to the negative 1, and we want to find dy on dx. So first thing we're going to do is I'm going to write down dy on dx, and I'm just going to think about the rule in my head. We do the exact same thing as we did before. So we bring our power down to the front, we multiply by this power, and then we reduce the power by 1. So bringing the power down to the front, I'm going to get a big negative 1. And I'm going to be multiplying that by 3x, and reducing my power by 1 goes to negative 2. Be careful with your negatives, your number becomes bigger, but because we've got the negative, it actually becomes smaller. Now we can simplify that up. We can say negative 1 times 3 is negative 3, and then we get x to the negative 2. And that is the derivative of 3x to the minus 1. Let's have a look at another example. So here we're given y equals 5x to the negative 4, and we want to find dy on dx. So I'm going to write down dy on dx. I'm going to bring my power down to the front to get negative 4, and I'm going to multiply by all of this and reduce the power by 1 to give us negative 5. Then I'm going to simplify that. Negative 4 times 5 is negative 20, and then adding my x to the minus 5. And that is the derivative of 5x to the negative 4. Now let's have a look at when your power is a fraction. So we've been given y equals x to the half, and I want to find dy on dx. So we're going to follow the exact same procedure. This power of a half is going to multiply to the front, so we're going to get a half lots of x, and we're going to minus 1 from the power. So a half minus 1, be very careful, is minus a half. And now we can do some tidying up. We can say that's a half x to the negative a half. We've just got rid of our brackets and distributed the half. Or we can say x to the minus a half over 2. Each of those answers are equivalent. Let's have a look at another example. So we've been given y equals 4x to the 3 over 2, and we want to find dy on dx. So we're going to follow the exact same procedure, bringing our power down to the front, so that we get a big 3 over 2. And then we're going to have 4x, and we're going to take 1 from our power. So 3 over 2 minus 1 is 1 over 2. And then simplifying that up as far as we can, we're going to get 3 over 2 times 4. 3 times 4 is 12, and we've still got to divide that by 2. And then adding x to the half there. And then dy on dx is going to be any simpler. Well, yes, 12 divided by 2 is 6, and then x to the half. And that is our answer. So hopefully now you can do basic differentiation.